Hey guys, last time we did we started off with plotting points. This time we're going to get into the meat of what's called, look at your chapter title, look at that, graphs of linear equation. Well, the word linear, the base of the root word is line. So we're going to graph lines basically. And if you remember last time, an equation that looks just like this was in black, and we went, oh, you have two unknowns. There's an x we don't know, and there's a y we don't know. There's two of them. Their degree is 1. So what will that give you? It gives you a line, okay? Now, I don't want you just to look at that equation and just duh, and not even understand what's going on, which I did throughout 4 years of high school and half of college. Look at this. Let's look at those numbers. I got a y. What does it equal? It equals 2 times some number plus 1. And here's a good setup. If you want to look at that below, this is the way you can. This is what y equals 2x plus 1 means in real life. Okay, let's say your father pays you $1 just for getting up. There's your $1, right? That's plus 1. Okay, he just pays you on a Saturday morning for getting up. Okay, he also pays you $2 for every can of garbage that you empty. Let's say there's tons of cans out there. I don't know, you own a park or something. Okay, well look at this. There's your $2. Okay, for every can that you, and there's your can. We'll call it, actually be the cans, okay? Well, you tell me how much money you're gonna make. Your dad says, I'll pay you $1 just for getting up and $2 for every can you empty, okay? Well, you tell me how much money exactly are you going to make? Okay, you should have thought, wait a minute, I don't know how much money I'm gonna make. Because I could do a ton of cans, man. I could do no cans. I could, try to get out of bed and fall and break my leg and not be able to do anything. That way I won't do any can. You could do 10 cans, you could do 50 cans, whatever. So obviously the answer is, how much money are you gonna make? Now that's the why. How much money are you gonna make here? Well, I'm gonna make, let's say, $2, and then this is the number of cans, and then my dad says, oh, just for getting up, out of the bed, he'll give me $1, okay? So the answer is, there isn't one answer to this equation. It depends. The value of y, how much money you're going to make, depends on, you tell me, the value of which over here. It's x, right? It's not the value of this, that's always 2. It's not the value of this, that's always 1. What changes things for the value of the y is how many cans you empty of trash. So that's what changes. So you can draw a graph of this. I mean, when you see graphs that are lines, I mean, they're not just like random nothing. I mean, they mean something, that you can tell things, okay? In other words, x is here still, y is here. They're positive, negative, and then positive, negative again, okay? And don't forget, the y is how much money you're gonna make, right? We don't know yet. The x is the number of cans, right? Cans. It looks like cars. Don't empty cars. Okay. All right. So we can actually sit here and plot points doing this and figuring out what to do. Well, I mean, this is how I would set it up at first, okay? In other words, let's take a look and let's just make up some numbers, okay? Plot yourself a little thing like that. Do 3 of them. 3 of them will tell you make you a pretty good line, all right? So, well, you tell me. Let's figure this out. The number of money you make, I'll draw it a little more clearly here. You know what? Let me use a green color so you can see it a little better. Let's say I got money I'm making is equal to $2 times the number of cans plus $1 just for getting up, okay? And that's the amount of money I'm making, okay? Well, let's just make up a number for the can right here. What if you get up but you do 0 cans at all? In other words, what if this x is 0? You do nothing at all. You just get up out of bed, roll out of bed, flop on the ground, break both your legs, and then run down the stairs on 2 broken. Don't do that. Okay. So if you do no cans at all, you get $2 times 0 cans, which is still 0, but you do get $1 just for getting out of bed, right? So for doing 0 cans, you hit $1. Let's just say you did 1 can. You took all day long and did 1 can. Well, $2 times 1 can is, $2. But you also get $1 for getting out of bed, right? Okay. So in other words, if you did 1 can, in other words, if the value of the x was 1, the can, then you would make $3, all right? How about another number? Let's say you did, I don't know, let's say you did 4 cans. Now, let's say, yeah, okay, let's say you did 4 cans. You did 4 cans, you emptied 4 cans. Well, you tell me, if you emptied 4 cans of trash, how much money would you make that day? you'd go 4 cans of trash. You make $2 per can, that's $8, plus the $1 for getting out of bed, you'd have $9, right? Okay. Now look at these green pairs of numbers, okay? I don't know if you noticed, but they're both X and Y's. So in other words, this is a point. This is a point. This is a point. In other words, like last time when we did, oh, graph 3, -10, or whatever, you went, oh, that's the X value, and this is the Y value, and I'll count over, and oop, there's my point. That's all we're going to do. It's just we're going to do these 3 points. So 0 and 1, which means the X value is 0. You don't go over left or right. You just go up $1. Oops, not too much there. Okay, that's a point. Okay, 1 and 3. If you do 1 can, remember these are the cans. If you do empty 1 can, you go 1, 2, 3. Boop, there's another one. Oop, did it again. Okay. Oops. Okay. That should be here. Okay. All right. We're done with that one. So if you did 4 cans, okay. In other words, you went 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Oop, there we go. Okay. Okay. So you can see what happens with those points. See how they line up? And there's your graph. Yoink, right there. So people, in other words, people in businesses and statisticians and people looking at, you know, all kinds of jobs, they'll look at this and go, okay, let's see here. I'll look at this and I'll predict, oh, if I do 20 cans, I can tell that the graph goes up to here. You know, they'll just look at that and figure out how they're doing, or if they did this much, many millions of dollars in advertising spending, and then they could expect this much as a result. Or and a lot of times these won't be perfect graphs. Like it might be something like this, or you know, kind of or whatever. But you can get kind of an approximate value by doing that. But anyway, okay. So that's the actual real life application of lines. It's not just some random thing where you just randomly throw in stuff. Here's another one. Let's say you're a babysitter, okay? And let's go here and go, a babysitting job, you get $3 just for showing up. All right, which means this is wrong. I'm gonna cross that out. You get $3 just for showing up. Let's say you're, I don't know, you're at homeschool mom's night out. Okay, you get $3 just for showing up and being willing to babysit whoever shows up. Plus, you're going to be there for an hour. You get $2 for every kid that shows up. Well, how much money are you going to make? Obviously, it depends on what? The number of kids who show up, right? Okay, so let's call the amount of money you're going to make, we'll just call it a Y. We usually deal with Y's and X's in these kind. The amount of money you're going to make is equal to, don't know how many kids are going to show up, we'll just call it X. Okay, we get $2 though for each one, and you get $3 just for showing up. Okay, so that is our equation. In other words, when you see this equation and they say, graph this equation or whatever, don't just do it just some random thing. You know, I mean, you can kind of visualize this as something. Ooh, I get $3 just for showing up, and hey, I get $2 for every kid that shows up as well, or $2 for every can that I empty, and $3 just for getting out of bed, or however you want to handle it. Okay, how much money are you going to make? Well, we'll figure it out. Okay, so let's do the same thing. Let's make us a little chart here of X's and Y's, plot some points here. Probably the easiest thing to do, and again, you want to do three points, because if you just do 2 points, let's say you do one here and one right there, and you go, and you don't realize you made a mistake. Well, if you do a third point, and the third point's way over here, you look at it and go, that doesn't make a line. What in the world? Then if you do 3 of them, you recognize they all line up. That convinces you that you've done it correctly. So I would do every single time a 0. That's the easiest thing to piddle with. And what you'll notice is, you know what? You tell me. You're in this babysitting job. No kids at all show up. How much money do you make? Okay. Well, it's 0 right here. No kids show up. 2 times 0, 0. Plus 3, you make $3. Oh well. So you sit there. So 0. There's my X. And there's my Y. How much money and how much, how many kids are showing up? Well, no kids show up, so you don't go left or right. You just go up 1, 2, and 3, like that. Okay? Well, let's say 2 kids show up. What the heck? All right? Well, you tell me, how much money do you make if 2 kids show up? Okay, if 2 kids show up, you get $2 per kid. That's $4 plus 3, $7. Well, there's another point. 2 kids show up. And then 1, 2, 3, 4, 5, 6, 7. Oops, did it again. Oh, hang on. There we go. Okay. All right. Well, let's say, I don't know, let's say you go crazy and by some weird time warp or something like that, the Twilight Zone, we have -3 kids who show up. I don't know how that works, but anyway, we'll just, what the heck, okay? So how much money are you going to make now if -3 kids show up? Well, you're going to go, okay, the amount of money I make is 2 times -3. Well, what's 2 times -3? -6, right? Well, then -6 and then plus the 3. What's -6 plus 3? -3, right? So if -3 kids show up, you make -3. In other words, the lady goes, thank you, and takes away 3 of your dollars, okay? Anyway, let's graph this point right here. -3, -3. So this time on the x, we'll go backwards, and then, and there it is. Okay, and if you notice, you know, there's your 3 points. They go like this, and that's the graph, and that's your graph, okay? And again, you can look at this. If you had a giant graph piece of paper, you could look at this and go, oh, I did 26 kids, and go all the way over here to 26. How much money would I make? Well, it would tell you here. It would stop way up here at the exact number you would make. Okay. In other words, you're looking at this now. You go, oh, I babysat 2 kids. How much money do I make? I go over here. Oh, $7. I made $7, which is exactly true. So, okay. All right. That's the practical use of lines. Okay. Let's do one more. Now this is weird. This is kind of a weird situation here. All right. So let's copy this down. Take a second here. Copy it down. If you need to pause it, go ahead and pause it. This is the graph. This is a weird situation. Let's try to apply it to, you know, I don't know, babysitting or trash cans or however you want to do it. Okay. Well, okay. Let's go. This is the amount of money you make. Okay. Now, just for showing up and doing nothing, you get $2, right? Okay. But the weird thing is, you don't get paid for everything you do. You get negative. You get -1/2. So like you could call it like having to pay 50 cents. You see what I'm saying? Okay, so this is not a good setup situation for you at all. So this is not a good job. I would quit immediately. Okay. So in other words, this would be like, oh, it's time to dump trash cans. Hey, you know, I'll stick you. Hey, get out of bed and I'll give you $2. Okay. And for every trash can you empty, you get -1/2 of a dollar. So probably your incentive is not to do anything at all, because every trash can you empty, you have to pay 50 cents. So you're going to lose money really quickly. So anyway, all right. But you can graph this. There are times where you know, negative numbers do play into graphs and experiments and all kinds of things. But let's do the same thing. Make up numbers for x and y. And again, I would always choose a 0 for x. That's the easiest thing in the world, okay? Because every time you choose 0 for x, this turns into, it just goes away. And the y value that you get is always just this number at the very end. If you notice back here, if I stuck in a 0 here for x, the value for y was just this. And if I stuck in a 0 for x here, well, the value was just this one here. So it always happens that way. You don't even have to think about it. So if x is 0, let's say you dump no trash cans, you still get $2. So let's graph it. No trash cans dumped. How much money do you make? None. You go up $2. Boom, there you go. Okay. Let's say you did, I don't know, 2 trash cans. All right. You dumped 2. You worked for 10 minutes and dumped 2 giant trash cans. Okay. So you're going to go, hey, Dad, you pay me. Your dad goes, okay, well, I'll give you $2 just for showing up. Let's see. You dumped out 2 trash cans. So each of those trash cans is going to cost you 50 cents. So that'll be 2 times 50. That'll be $1, son. You know, okay. So I did 2 trash cans. I get paid $1. That stinks. Okay. So I did 2 trash cans, and I got $1. Not very good money. Okay. All right. Let's say you worked really hard and you dumped 4 trash cans. Really got to it. Okay. Dad, ready to get paid. He's like, okay, here's your $2. Okay. Just for doing nothing, you get $2. Okay. Just for getting out of bed. Let's say you dumped 4 trash cans. That's the number here, the x. Okay, so a -1/2 times 4, that'll be -$2. So you owe me $2. And then you look and you have nothing left at all in your hand. And you run off and fall down to the gutter and start crying. Okay, well you can see what's going on here. Well, let's go ahead and graph this first. 2 and 1, I thought we already did that. 2 trash cans, you made $1. If you did 4 trash cans, 1, 2, 3, 4, you got nothing at all. Look at how this graph is going. Now, what looks different about this graph, the line, than the previous couple of graphs there, right? Look at that one. Look at that one. Now look at this one. You notice anything different? Obviously, it's going down, right? Okay. The reason it's going down is because this is a negative number. We don't have to get too much into that right now, but we will later on. So just know that. Okay. So that is a graph. We tried 3 numbers. They all, lined up nicely, and there we go. Okay. Let's try another. This is a weird one. Look at this thing. What's missing on this graph right here? Yeah, I mean, there's nothing there, right? Okay, so this is almost like plus 0. In fact, if you want to write plus 0, go ahead. You can do that, okay? The setup is your dad goes, "You're going with me." You go, "Okay, where are we going to go?" "Well, you get nothing for getting up out of bed. Nothing at all. And for every garbage can you empty, you get $-1. No, for every kid you babysit, let's say, you get $-1. Because there's a 1 there, if you want to assume there's a 1 there. So this is a terrible situation. I would pretend to have, like, I don't know, the bubonic plague or something immediately to get out of this. Okay, because look at your setup. This is horrible, right? If you do no kid, or let's say you babysit no kids at all, remember, this is if the x is equal to 0, your answer is for y is always whatever's to the right. So there's nothing there. So here you go. Doink. There's your 1 point. But let's say you babysit 2 kids, right? Well, if you get nothing anyway. So you babysit 2 kids. He charges you $1 for every kid you babysit. So you have to end up paying him $2. That's horrible. So there's your point. Don't forget x here, 1, 2, and then -2, doop, doop, going down. Horrible. Okay? Well, let's try this. Let's say you enter the twilight zone and you go, "Okay, I'm not going to babysit kids. I'm going to unbabysit kids," which means I'll do -5 kids. I don't know how that's possible, but hey, we can try anything here. Well, if you do -5 kids, in other words, if you put -5 in there for x, the amount of money you're going to make is negative, some times the x is -5. Right? I'm sure you know the value of the opposite of 5 is just 5, right? So if you unbabysit 5 kids, then you end up making $5. So that's the secret. Try to find out how to unbabysit, whatever in the world that does. Is it like taking food out of kids' mouth and unchanging their diapers? I don't even want to know. Anyway, your x value, don't forget, this is your x and this is your y. If your x value is -5, 1, 2, 3, 4, 5, that means your y value, look at it, is 5. 1, 2, 3, 4, 5. And you notice again, there's your line. I can't draw a straight line, but there you go. And again, notice the line's going down. And so the ones we had earlier that were going up. And the reason for that is, again, look at this right here, that negative sign right there. That's what makes it go down. Lines with positive numbers like this, like a +2, and like a +2 here, they go up. They point like it's, oh, good, our company's doing better. Ones with -0.5 and -1x, they go down. Okay? All right, let's look at, this is the last type of line we're going to look at today, vertical and horizontal lines. Obviously, there's your horizontal line, and there's your vertical line, okay? When an equation is missing an x or a y, and don't forget, these are our equations, y equals -x plus 0, y equals -1/2 x plus 2. When it's missing an x or missing a y, it's either vertical or horizontal, okay? In other words, you're going to see this, okay? You'll see something like this. Instead of, excuse me, x and y, you'll see y equals 3. X equals 3. Well, there's a typical, like, graph, right? Well, if the x is equal to 3, well, this is the x-axis, right? Well, if x equals 3, that means 1, 2, 3, right? Well, if x is always equal to 3, it'll look like this. It'll just be going up and down. It'll be a vertical line. Okay? Well, let's do this. If you have something like this, excuse me, y equals -1. Well, of course, this is your y-axis, right? And whenever you find a y value, it's going to be on this axis. So if somebody says to you, oh, y is equal to -1, you know it's down here, right? That's the part that's negative for y. Excuse me. Well, if y is always equal to -1, well, then it's always equal to -1. It looks like this, okay? So x's are vertical lines. X equals is a vertical line. Y equals is a horizontal line. So that's how it's going to look. All right? You'll see several of those in your practice problems as well. Okay. All right, here's one for example. X equals -2. Well, don't forget. There's your X and there's your Y. Okay. The setup, you want to make this like one of the babysitting problems. Okay. You know, forget it. We'll just draw it. You plot points. I mean, the X is going to be -2. Well, where is X is -2? Okay, there it is. -1, -2. There it is. X is always equal to, oh, brother. It's supposed to be a straight line there. X is -2. Boom, there you go. Okay. This one, Y is equal to 4. Well, don't forget, this is your x-axis. That's your y-axis. If the value is always y is always equal to 4, that's positive. So 1, 2, 3, 4. So your value of y is always going to be that. So you can just write or draw a horizontal line right there. Don't worry about the setup of plot points. Okay. All right. Let's look at 2 of these on the same system. And sometimes this is interesting. We'll do something with this later on. That is one of the weirdest things in algebra. Now let's graph both of these on the same. In other words, when they say the same rectangular coordinate system, that means the same piece of graph paper. By the way, you can go on the internet and just print off on your printer pieces of graph paper if you want. You can go anywhere and get these. Or what you can also do is you can see this picture right here. You can find pictures of like small pictures of parts of a graph like this, and just print them 3 or 4 or something like that on one piece of paper, and then just print a bunch of copies and then put them in your notebook, punch holes in them or whatever. So, all right, well, let's do this one first. Y equals 2x. Okay. Before we graph this, let's think about what this means. Okay, in terms of let's say babysitting this time. Okay, so babysitting. Your dad says, "I'll pay to babysit." Okay, and don't forget, this is the amount of money you make, right? Okay, and what does this 2 mean right here? You tell me. What does the 2 mean in this babysitting wise? Okay, it means for every kid you babysit, you get $2, right? How much money are you gonna make? Don't know. Depends on how many kids are there, right? How much do you get for just showing up this time? You get zippo, nothing. So if you want to put a +0, go ahead and do it. All right, here's your graph. You're plotting points here, and immediately you think, okay, if I do no kids at all, babysit no kids, then of course I make no money. Well, 0, 0, there's my point, right? Oh, right there. Missed it. Okay. All right, let's do another point. Let's say you babysit 1 kid. How much money do you make? You tell me. Babysit 1 kid right here. You make $2, right? And there's another point. Okay, the x is 1, and the money you make is 2. Boom, there we go. Okay, let's say you babysit 2 kids. Easy enough. How much money do you make on that time? $4, right? Okay, so babysit 2 kids, 1, 2. You make $4. 1, 2, 3, 4, and there is your approximately line. Okay. All right, let's do the second one. The second line is that y equals 2. Well, which means, don't forget, this is your y-axis, there's your x-axis, which means the value, no matter what happens, the y value will always be 2. A positive 2 is right here, okay? So you just draw the horizontal line, and then there we go. You can draw them both in the same thing. What that means, we don't know. We could look at something later on and tell what it means a little bit better. So, okay. All right. Go ahead and give your practice problems a whirl. You're going to graph each one of these and try to just very quickly tell yourself which each one of them means, either in a babysitting example or a, I don't know, load of laundry example or picking up trash or whatever example you want to. So go ahead and pause it and let's do A. Okay, let's take a look at A here. We'll do dark red. Okay, here we go. And the setup of this is, let's put a 1 there. This is a bad setup for you work-wise, okay? Because your dad tells you, I'll give you $1 just to get out of bed, okay? But for every kid you babysit, you have to pay me $1. So not a good setup, okay? But let's graph it first, okay? Put some things in there. In other words, if you do nothing at all, you don't touch any kids at all, don't babysit at all, no kids means you make $1, right? So 0 kids, there's your X and there's your Y. 0 kids means you make $1, okay? If you babysit 1 kid, you think you're doing well, but your dad says, you babysat 1 kid, give me $1. And wait, you say, well, give me the $1. Okay, then we don't, neither one of us has anything. So if you babysit 1 kid, you get nothing. So if you go over 1 at the X, you stay here at the at 0. Okay. Let's say you babysit 2 kids. So you go, oh, I made $1 just getting out of bed, but your dad says, yeah, that'll be $1 for each kid you babysat. So you owe him $2. He owes you $1. So you end up actually owing him $1 because you owe him 1 more than he gives you. So if you babysit 2 kids, 1, 2, you owe him $1, -1. There it is. Okay, so there is your setup. And again, notice this thing is going down, and the reason it's going down is because of that negative X. Okay. All right, let's pause it and try B. Okay, B is not a very good setup either, although it costs you less per kid. You get $2 just for, let's say it's garbage cans. You get $2 just for getting out of bed, but every garbage can you empty costs you $1/3 of $1. Okay, so what I would do if I were you, when I'm picking points on this one, 0 is the easiest thing. Let's just go ahead and do that. If you do 0 cans at all, you just get out of bed and sit there and stare at the wall for 8 hours like you're at a homeschool prom, you get $2. So 0, X is 0, you get $2. Boom. Okay. So anytime you see a fraction like this, look at the denominator, use that, a multiple of that denominator. In other words, I would use 3 and I would use 6 to make it a lot easier on myself. Because you don't be messing with fractions and, oh, I made 4 2/3 to all that. Just use 3 and 6. If it was, y equals -1/5 x, blah, blah, use 5 and 10. Just keep doing that. Okay, so let's say you did 3 trash cans, which means your dad goes, here's $2, okay? And he goes, okay, you did 3 trash cans, so -1/3, oops, times 3, that's going to be negative, you owe me $1. And you go, okay, you just paid me $2, so I owe you $1 here. Gee, I made $1, okay? In other words, if you did 3 trash cans, 1, 2, 3, you made $1. Not too good, okay? All right, let's say you did 6 trash cans, you went crazy. Well, same thing, right? -1/3 times 6. Well, you tell me what's a -1/3 times a 6. Forget the negative. What's 1/3 of 6? It's 2, right? So that'll be -2. So you owe your dad $2. But he also owes you $2 right here, so nobody makes anything. You babysat, oh wait, you did trash cans. 1, 2, 3, 4, 5, 6 trash cans, you got no dollars at all. There's your line. Okay, not a very good situation. Okay. Okay, let's pause it and do C. Okay, C is this one, X is equal to 3. Don't forget this is your X-axis. The X is equal to 3 is right here. 1, 2, 3. Well, there it is. And if you're just going to say every single time X is 3, then there it is. X is equal to 3. Okay. And that makes Y is equal to -4 a lot easier to do. We can do that next. Okay, Y is equal to -4. There's your Y-axis. 1, 2, 3. That's -4. So your line will look like this. Okay. There we go. Okay. Hope you guys enjoyed that. See you next time.